So in the last video, we applied the power rule to power functions, which were very simple, basically functions of this form, ax to the n. All we did was we dropped the exponent down, multiplied by the coefficient, and subtracted this guy by 1. That was the derivative, so it ended up looking something like anx to the n minus 1. That was the derivative. We also applied that power rule to a polynomial function, and we just applied the power rule term by term. Now, here's the question. What if you are given a reciprocal function, which kind of looks like this? Or a radical function, which we'll talk about in the next example. What do? Well, you could still apply the power rule to get the derivative. The only thing is, first you have to convert the power function, the reciprocal function into a power function. And you learned that in grade 11 math, or at least you should have. So basically, step 1 in this process, if you want to find the derivative, step 1 is convert reciprocal or, oh, I think I spelled it right the first time. Reciprocal or radical to power. Step 2, apply power rule. It's that easy. So how do you apply the, how do you convert a reciprocal to a power, right? So here we're given a function f of x, 5 over x cubed minus 0.4 x squared. Here's what you do. You basically take this reciprocal, okay, and you flip the ratio. So what that translates to is you bring that x to the top. Instead of being on the denominator, it's now on the top, on the numerator, okay? And now you switch the sign to negative on the exponent. So I call this, going from here to here, I call that flippy switchy, because you flip the ratio and you switch the sign. Flippy switchy. Okay, now when I apply the derivative, I just apply the rule that I learned in the previous video. So I bring that negative 3 down to multiply by 5, and I get negative 15x to the negative 4. It's negative 4 because it's negative 3 minus 1. So I still subtract by 1. Here I just apply the regular power rule because that isn't a reciprocal function. So you get 0.8x. And there you go. That's the derivative. Now it wants the slope when x equals 2 and x equals 4. So I'm basically plugging in two values of x. 2 and negative 4. Let's do that. So negative 15, 2 to the negative 4 minus 0.8 times 2. And all you do is evaluate it and see what you get for the slope. Bear in mind, I could have also switched this back to having a positive exponent by now bringing it back to the denominator and applying flippy switchy in reverse and switching the sign back. Could have also done that. So keep that in mind. Now, step 1 in the process was convert reciprocal or radical to power. Okay, you do the exact same thing with the radical function. So radical function is of this form, and it's a radical form. So this is radical form, radical, but you can also convert it to exponential form. So what we have to do is we have to convert any radical function into exponential form first, and then determine the derivative. And that's it. So here we go. I'm going to convert this thing to an exponential function. Now you see that 3 there? That 3 is the denominator inside the exponent. Okay, so that b right here should go on the denominator. So that's what I'm going to do. I'm going to put that 3 on the denominator. I'm going to rewrite this term as 1 over 4 x to the 5/3 plus 6, and then I'm just going to apply the derivative. I bring the entire exponent down and multiply it by the fraction. And then when I apply a derivative on a constant, it's 0. Okay, so I basically don't even have to include anything there. Subtracting 1 from a fraction, I would need to do common denominator, which is 3 over 3, and I end up getting 2/3. And there you go. Now, they want two things, the slope, or the derivative, and the equation when x equals -8. So here we go. All I'd have to do is plug in -8, and this is the slope when x equals -8. Now you should get, let's see, so you get, what, 20 over 12, which is 10 over 6, which is 5/3. Okay, so the slope is 5/3, and now all you have to do is find the equation of the tangent. Okay, now the equation of the tangent has the form y equals mx plus b. Now we literally just found m, so all you need is the y-intercept. To get this, plug in a point xy. How do we get a point xy? Well, we have x. X is -8. How do we get the y value? Well, you can plug in x equals -8 into p of x, because that will give you the y value. So let's go. P of -8 equals -8 to the 5 cubed root. Now the cubed root of -8 is -2 to the power of 5 is -32 over 4 plus 6 equals -8 plus 6 equals -2. So all you have to do is plug in the point. So you go -2 equals 5/3 of -8 plus b. So -40/3 minus, what, 6/3 plus b. And you end up getting 34/3. And so therefore your equation equals 5/3 x plus 34/3. And there you go. That is the equation of the tangent. Now, what if I give you a rational function? It's the same process. I have to do step 1, which means convert it into a power, okay? And then apply the power rule term by term. So this constitutes a rational function. The reason is because you've got a polynomial on top and a polynomial on the bottom. It's the same process though. So let's do this. So I'm going to convert it, and this is a dividing line, right? So it's a division line. We're going to divide 12x squared to each term on the numerator. So I'm going to split this basically down the middle. And 12x squared has to go to each term. Now I can resort this and turn it into a power function. So 16 over 12 let's see, it can be reduced to 8/6 or 4/3. And then I could apply flippy switchy on this x to the 2 to produce x to the -2. Here, I could apply a power law, right? When you divide powers with the same base, you subtract the exponents. So you get x cubed. And then the coefficient in front is just 1/12. There you go, I've converted it. If I want to apply the derivative, I apply the power rule. Let's do it. -8/3 x to the -3 minus 3/12 x squared. You get -8/3 -8/3x cubed minus 1/4 x squared. Okay, so now we need to figure out the equation of the tangent line, okay, when x equals -1. So you need the slope and the y-intercept. So what I'm going to do is I'm going to plug in -1 into the derivative. So let's do that. -8/3 to -1 cubed minus 1/4 -1 squared. Now the cube of -1 is -1. Two negatives make a positive, and so you end up getting 8/3. The square of a -1 is +1, and so you end up getting -1/4. If you were to subtract these, common denominator and all, you would get, let's see, 32 minus 3 all over 12. You would get 29/12 for the slope. Check that for yourself. Now I've got the y-intercept. All I need is, excuse me, I've got the slope. All I need is the y-intercept. Okay? So how do we do this? We need a point on the plot. We've got the x-coordinate. All I do is plug it in to get the y-coordinate. So y equals 16 minus -1 to the 5 over 12, -1 squared. 16 plus 1 all over 12, 17/12. So now all you have to do is plug this in to get the y-intercept. So you plug in y, you plug in m, you plug in x to find b. On this side, you've got -29/12. Here you've got 17/12. You've already got the common denominator. So if you bring it over, you end up getting 46/12 for the y-intercept. Therefore, your equation of the tangent is going to be 29/12x plus 46/12. All I do is I plug in the slope and the y-intercept. So that's it. The rest of it is a plotting, basically, of this line. But yeah, all you do is plug in some x values, find the y values approximately, connect the dots, and you've got a line. That's it. That's basically the power rule as applied to reciprocal, radical functions, even rational functions. And we also applied it to polynomial functions in the last video. So we're pretty much done with power rule for now. Next up is product rule. All right, see you in the next video.